A 76 kilogram person is on a 45 kilogram boat, both initially at rest. If the person jumps off the boat with a velocity of 2.5 meters per second to the right, what is the final velocity of the boat? Well, this is a law of conservation momentum problem. And the question gives you some characteristics about the person on the boat, 76 kilograms, and the boat itself, which is 45 kilograms. Now, the very first sentence talks about the condition before anything interesting happens. In other words, what's the momentum in the beginning? It also tells you that they are initially at rest. So that means that velocity initial is 0 meters per second. It also means that velocity initial of the boat is 0 meters per second. So the givens, if we want to talk about this as the person and this is the boat, I can record that mass of the person is 76 kilograms, and the velocity initial of the person is 0 meters per second. For the boat, I can go that the mass is 45 kilograms, and the velocity initial of the boat is 0 meters per second. Now, if I wanted to figure out momentum, net, I simply take the mass times velocity of the boat. So in this case, equals 76 times 0, plus the mass times velocity of the person, plus mass times velocity of the boat, which in this case is 45 times 0. Now, I hope that this is pretty obvious that look at this number blows up and this number blows up because any number you multiply by 0 is 0, and so the net force in the beginning equals 0 kilograms times meters per second. Well, that's all well and good, but then the second half of the problem changes things up a little bit. It explains that the man, he leaps off the boat this way at a velocity of 2.5 meters per second. And then, what is the final velocity of the boat? We are looking for what the velocity of the boat is. Now, the law of conservation and momentum says that the momentum in the beginning equals the momentum in the end. And I can use that in order to help me solve this. So I know that the mass of the person remains the same, 76 kilograms, but now I have a new velocity. The velocity is 2.5 meters per second. I have the mass of the boat remains the same, 45 kilograms, but I am looking for what the velocity is. Final equals question mark meters per second. Now, the law of conservation says that my net momentum needs to be the same. So in this case, it's 0, which equals the mass of the boat, the mass of the person, 76, times its velocity, 2.5, plus the mass of the boat, which is 45, times boat's velocity, which I don't know. When I simplify this aspect of it, I get 190, and I will bring 45 velocity down. In order to remove this 190 from the right side, I'm going to subtract 190 from the right, but whatever I do to the right, I have to do to the left. And then in order to get V all by itself, I'll divide by 45. So that these two cancel, leaving me with a velocity of negative 4.2 meters per second. Now, technically you're done, but I want to discuss why the negative is terribly important. You will see that the man jumped to the right. What direction does the boat go in? It goes to the left at negative 4.2 meters per second. And this is kind of a continuation of Newton's third law that every action, every momentum to the right, is an equal and opposite reaction as momentum to the left.